Hey everybody, so today we're going to talk about naming organic compounds and hydrocarbons. So this is going to be the last compound that we name, and I know it's getting a little confusing because we have so many different types of compounds that we have to name. So far we've named the binary ionic compounds, and those are going to be the ones that have two capital letters. One is going to be a metal, and the other one's going to be a nonmetal, and those are going to end in IDE. So things like magnesium chloride, strontium chloride, sodium fluoride, all of those different ones. And then the next day we talked about how to name the polyatomic compounds. And the polyatomic compounds have a metal and then a polyatomic ion from your polyatomic ion sheet. And those usually end in ate, ATE, or ITE. Then earlier this week we named the ones that were covalent, meaning they had two nonmetals in them, and you had to use those prefixes like mono, di, tri, and the next one ended in IDE as well. So today we're going to talk about these things called organic compounds and hydrocarbons. So what is an organic compound? These are going to be covalently bonded together, so they're going to be nonmetals, and they are only going to have what they call carbon and hydrogen in them. And I'll talk about hydrocarbons here in a second. So carbon has the ability to bond with itself in these long chains, these rings, all kinds of really interesting things. And if you're really interested in this, there's a whole college course you can take called organic chemistry, and it'll take you an entire year, and it is very difficult. So carbon has 4 valence electrons. So in theory, it can bond to 4 different things. And since it can bond to 4 different things, that's going to make it, pretty, the word they usually say is ubiquitous, and ubiquitous is just a word that means everywhere. So carbon also bonds very easily to elements that have similar, what they would say, electronegativity. And electronegativity is a fancy science word that just means how badly does an atom or an element want electrons. And the number that has the highest value for electronegativity is going to be fluorine. So fluorine, F on the periodic table, wants electrons, the most, and it'll do anything it can to get that last electron because it already has 7 electrons and it wants to get one more to get that 8 electron. And that was called the octet rule. So let's talk about these things called hydrocarbons. So where did they get the name hydrocarbon from? Hydrogen plus carbon equals hydrocarbon. So hydrocarbons are going to be chemical compounds that have carbon and hydrogen only in them. They have nothing else. They don't have any oxygen. They don't have anything like that. So they have special words that they called them. All right, so this first one here, we've got hydrocarbons that only have single bonds between the carbon molecules. Those are going to be called alkanes. All right, so A-L-K-A-N-E-S, alkanes. And when I say single bonds, it's going to be represented by one single line. And it's going to mean that they're sharing 2 electrons, all right, between the carbon and the carbon. All right, the next one is called an alkene, and notice it's a slight change. So we went from an A here to an E here. And if you have at least one double bond, that's going to be called an alkene. If you have a triple bond between any of the carbons anywhere, that's going to be called an alkyne. So notice that it went from alkane with an A to alkene with an E, and then alkynes with a Y. Okay, and a lot of times they will show you these hydrocarbons in this thing called a structural formula. And sometimes the structural formula might be called like the, this bones or something, looks kind of like bones or something. So this one has 3 carbons, all right, and these lines show that the 2 elements are bonded together. So one line means that they are sharing 2 electrons. So there's 1 electron coming from this one and 1 electron coming from this one, and they're sharing those 2 electrons here in the center. All right, so this is another example. They're all single bonds between the carbons. All right, you can only have 1 line between a carbon and a hydrogen. You can never have like 2 lines to show a double bond between a carbon and a hydrogen. All right, so there could be 2 lines between the 2 C's, but there can never be more than 1 line between the C and the H. All right, so let's talk about alkanes. All right, so alkanes are going to have single bonds between all of the carbon atoms. And all of them, they have this chemical formula CnH2n plus 2. So what does that mean? That means that the number of carbons that it has you're going to take that number, double it, and then add 2, and then that'll get you the number of hydrogens that it's supposed to have. All right, so let's say that this number is 2. All right, C2, and then we want to figure out how many H's it should have. H2 times 2 plus 2, so 2 times 2 is 4, plus 2 is 6. So the correct chemical formula for this one would be C2H6. Okay? All right, so to name these carbon molecules, or these ones that have single bonds, you're just going to find the longest chain, and you're going to use the prefix from the next slide and add ANE to the ending. So let me show you what these carbon chain prefixes are. So you've got meth, eth, prop. This is not but, it's bute. Pent, hex, hept, oct, non, and dec. So let's say that we have one carbon and it has single bonds. It's going to be meth and then ANE, so methane. All right, if it has two carbons and they have single bonds between them, it's going to be called ethane. 3 is going to be called propane, and so on and so forth. All right, so here's some examples of alkanes, and these are the ones that you're probably most familiar with. So methane, I put this cow here. He's got some flatulence going there. Flatulence is a fancy word that means farting. And cows actually release methane, and methane is a potent greenhouse gas, and it's heating up the atmosphere, all that kind of stuff. Then there's propane. So if you have a propane grill at home, that's going to have the chemical formula here, C3H8. It's a liquid inside of here, but then when it comes out, it's a gas. All right, next one is called butane, and they have these little lighters, and those have butane in them. That's what they use to set on fire. And then octane, you're probably most familiar with because that's what cars run on. All right, so it says name these alkanes. All right, what's the name of this hydrocarbon? What you're going to do is you're going to say how many carbons are there. So we've got 1, 2 carbons here. We're going to go and look up that prefix. So if you click back onto slide 6 here, we had 2 carbons, right? So we're going to find the prefix, which is eth, E-T-H. All right, and now we're just going to add A-N-E to the ending. And why did we add A-N-E to the ending? Because there's a single bond here. If it was a double bond or a triple bond, the double bond has 2 lines, the triple bond has 3 lines. All right, now let's go to this next one down here. It's count the number of carbons. So we've got 1, 2, 3, 4. Let's go back to this slide here. We've got 4 carbon atoms. So the prefix is going to be bute. It's not but. And then we're going to add ANE to the ending. All right, it doesn't matter how many hydrogen it has. It's just filling in the space here. So remember, carbon can bond to 4 different things. All right, so it's bonded. This carbon here is bonded to another carbon and then 3 hydrogens. So the hydrogen just fill in the space, and they don't have anything to do with the name. All right, let's talk about alkenes. Alkenes with an E here, so notice there's a slight difference. They're hydrocarbons, meaning they only have one hydrogen and, they only have hydrogen and carbon, and they contain at least one double bond. And a double bond is going to be 2 carbon atoms sharing 4 electrons. All right, so what you want to do is you want to count how many carbons there are in the longest continuous chain, and then you're going to use the prefixes and add ENE to the end. And again, we've got this general formula here. We've got CnH2n. All right, where N is the number of carbons that you have here, and H is going to be 2N. So let's say if this is C3, to figure out the number of H's, you would just multiply it times 2. 3 times 2 is 6, so C3H6. All right, so naming these alkenes here, the first thing you want to do is you want to count the number 1, 2, 3, 4. All right, so we've got 4 carbons there, and it's got a double bond here. That's what these 2 lines here, it looks like an equal sign. So we've got 1, 2, 3, 4. Let's go back to this slide. 4 is going to be bute, all right, and then we're going to add the ending ENE because that is a double bond here. So this is going to be butene. All right, the next one here, 1, 2, 3, 4, 5. We've got 5 there. Let's go back to the prefix slide. All right, 5 is going to be pent, like pentagon. All right, and it's got a double bond here. So that's what this little equal sign looks like. So it's going to be pentene. All right. All right, the last one we want to talk about are these things called alkynes. So notice again, it just changed one letter. It's alkynes with a Y. So if it has a triple bond between any 2 carbon atoms, it's called an alkyne, and what you're going to do is you're just going to add YNE to the ending. So the chemical formula for this is going to be CnH2n minus 2. So let's say that this is like 4. So C4H, 2 times 4 is 8, minus 2 is 6. So C4H6. All right, naming these alkynes. All right, so if you notice, there's 3 lines in between here. 1, 2, 3. All right, so this is going to be a triple bond here. So we've got 2 carbons, 1, 2. All right, so if you don't remember what the prefixes were for those, let's scroll back up here. So we had 2 carbon atoms, so it's going to be F. All right, and then we're going to add YNE to the ending. All right, so this one is going to be ethine. And I know these sound really weird, but, you know, scientists came up with these rules. All right, so let's count the number of carbons here. 1, 2, 3, 4. All right, so that prefix is going to be but, B-U-T. And then we're just going to add YNE to the ending. So butine is the name of this one. The next thing that I want to talk about are these things called benzene rings. Carbon can also bond with itself in rings. And when you have a carbon, carbon bonds that are in a ring, you just add the prefix cyclo. So cyclohexane is just going to be a ring of 6 carbons in all singly bonded to each other. So benzene is actually a 6-carbon ring, and it has alternating double and single bonds, and it's really interesting. This is what it looks like, and it's very, very common in organic chemistry. So this is the one that I know as benzene. So if you're interested in that, you can go do some more research about that. And I'll leave you with this joke. Organic chemistry is difficult. Those who study it have all kinds, you get it? You get it? Of trouble. And that's it for me for today. I hope you enjoyed this video. I hope you have a great day. See you later.